In this example, we're going to use integration by parts, and we're going to let u equal 5x, because when we differentiate it, the x disappears. So, write out the rule for integration by parts, let u equal 5x, let dv equal e to the 4x, and try working it through. I'll just pause this while you have a go. So we can write down what u and dv are, and then we can differentiate u and integrate v to get this, and then we can put them into the formula for integration by parts. So if you can carry on from here. So we've got u, 5x, times v, a quarter e to the 4x, here, minus the integral of v du, v, quarter e to the 4x du, which is just 5. Note I've put the whole lot, because it's a definite integral, I've put the whole lot in square brackets. The uv and this integral have all got to be inside that limit box. I'm going to tidy up before I put the limits in and try and take out constants if possible, and that's actually quite handy in this case, because if you look inside the box, this can be 5 over 4 x e to the 4x. I can bring the 5 over 4 outside the integral e to the 4x dx. So actually, because the 5 over 4 is common to both, I can take it outside the square bracket, which all helps when you're coming to put your limits in. It doesn't mean to say you won't get the right answer, it's just a bit longer. So all I'm left with now is x e to the 4x minus whatever the integral of e to the 4x is. So that's a standard integral which I can do. So it equals 5 over 4 x e to the 4x minus e to the 4x over 4 between 0 and 1. Integrating e to the 4x is e to the 4x over 4. And now just let x equal 1 and 0. Give yourself some room. So putting limits in, 1 e to the 4, so that'll be just e to the 4 minus e to the 4 over 4 minus, putting the 0 in, everything's going to be 0. Oh no, e to the 0 is 1, so that's just going to be minus a quarter in there. Just look at that, see if you can see it. So I might end up with something that looking like that at the end, and then I could work out what the answer was.